20th, 1969, humans walked on the surface of the moon for the very first time. Black and white images of the moon's surface flashed on television screens everywhere. The whole world was watching. Let's journey back to that time for the first-hand account of the historic event.
This is Jane Wilson reporting live from the Mission Control Center in Houston. As you know, 4 days ago on July 16th, the Apollo mission lifted off from Cape Canaveral, Florida. The 3 astronauts on board have traveled 240,000 miles, or 400,000 kilometers to the moon. In just minutes, they will attempt the first moon landing. Their spacecraft has separated into two parts, the command module, Columbia, and the lunar module, Eagle. Columbia is piloted by Mike Collins. It will orbit the moon while Eagle, piloted by Neil Armstrong and Buzz Aldrin, makes an historic landing. Let's go to Pete Brooks in the studio for a historical perspective.
Thanks, Jane. I'm here with Dr. Vargas. He is an expert on the history of the United States space program. Dr. Vargas, why is this mission so important?
For years, Pete in the United States competed with the Russians. To have the best space program, it's all started on October 4th, 1957, when the Russians launched Sputnik, the first satellite. Then on April 12, 1961, Yuri Gagarin, a Soviet cosmonaut, became the first person in space.
Americans were taken by surprise.
Absolutely, they felt defeat.
What turned things around for the U.S.?
In 1961, President Kennedy challenged us to put a person on the moon by 1970, and today the world is witnessing all efforts to fulfill the challenge.
Thank you, Dr. Vargas. Now let's go back to Mission Control. Jane Wilson. Jane, are you there?
I am, Pete. The command center at Houston is a huge room filled with workstations. At many of these stations, mission control experts monitor important data coming from the Apollo 11 spacecraft. You can feel the tension in this room. Right now, I am standing with some very special visitors. With me is astronaut Mike Collins' wife, Emma, and their 2 children, Todd and Amanda. We are joined by 2 mission control experts. Can you tell us what is happening now?
We're standing in our communications area. This is where we monitor the instruments on Columbia and Eagle.
Wow! I've never seen so many computers in one place.
If you think these are impressive, you should see the Columbia Command Module. That's where your dad is now. Behind the module is the service module. That's the part of the ship that holds fuel, oxygen, and navigational equipment.
We were really proud of you, Dad.
Would you like to speak to him now? We have Columbia on our radio here. Say hello.
Hi, Dad.
Hi, kids.
I wish we had a telescope that could let us see him.
Todd, the most powerful telescope in the world couldn't see something as small as the Columbia. It's too far away. Your mom's right. Think of how far away your father is. His rocket goes 24,000 miles per hour. And it still took him 2 days to get to the moon.
My dad went 24,000 miles per hour?
That's right. And do you know why? There's no air and very little gravity in space, so you can travel very fast. Newton's first law of motion states that once you are moving, you won't stop or change direction, unless a force acts on you. In a car, friction with the ground constantly slows you down. In an airplane, air resistance works against forward motion. But in space, there's nothing to stop you.
But because there's air and gravity on Earth, it took tons of fuel to lift off, right?
Right. Remember the rocket that launched this mission had 3 stages. The first stage had 7.5 million pounds of thrust. That's a lot of power. The rocket pushed off the ground on a jet of superheated gas. The second stage needed less than half the power because the rocket was lighter after all the fuel burned off. The third stage was the smallest, even though it carried the astronauts the farthest.
But if there's no air to push against in space, how does the rocket move forward?
Good question. That's Newton's second law of motion. Every action has an equal and opposite reaction. When the exhaust gases leave the rocket, they push back and the rocket moves forward. On liftoff, the force of the exhaust gases moving down propels the rocket in opposite direction, up with the same force.
Dad, are you still there? What did it feel like during liftoff? We were 3 miles away and we felt the ground shake.
It squashed us in our seats until we could barely breathe. It added G's, or gravitational forces. Right now, Amanda, you feel 1 G. On liftoff, we felt 3 G's. It was like being at the bottom curve of a roller coaster.
Cool!
You need all that thrust at liftoff because the rocket is so heavy.
But it weighs almost in space, right?
If your dad wanted to, he could push the ship with his hands.
That's pretty amazing, isn't it, Amanda?
Mom, did you say Buzz and you won't weigh much on the moon?
Yes, I did, Amanda.
Your mom's right. Another one of Newton's laws says that gravity attracts all masses to one another, and the greater the mass, the greater the gravity. The moon's mass is about 1/80th the mass of Earth. Its gravity is about 1/6 the gravity of Earth. On the moon, the two astronauts who will walk on the moon each weigh 360 pounds with their spacesuits on. On the moon, they only weigh 60.
I'm sorry, but I have to interrupt you now. We have the lunar module on the line. Neil, what is your status?
We're approaching the landing site. It looks pretty rocky. I'll keep moving to see if I can find a smoother spot.
This is Jane Wilson reporting. For those of you who just joined us, we are here live at the Mission Control Center in Houston. Neil Armstrong and Buzz Aldrin are about to touch down on the moon in the lunar module. In just moments, if all goes well, they will step into the vacuum of space, relying on their spacesuits to protect them from the harsh conditions. In case you were wondering, the moon can be a scorching 243 degrees Fahrenheit during the lunar day and a frigid 279 degrees below 0 Fahrenheit during the lunar night.
Eagle, this is Mission Control. You have to set down to 0 on fuel.
Roger, Mission Control. We have found a landing spot.
What happens if they crash?
The Eagle is moving very slowly. A crash would only break the legs. The section with the legs remains on the moon after liftoff.
There's absolute quiet here at the Mission Control Center as everyone waits.
Mission Control, this is Tranquility Base here. The Eagle has landed.
There you have it. The Eagle has landed. Those are the words of Neil Armstrong, the first words spoken from the moon. The lunar module has just landed on the Sea of Tranquility, one of the dark areas on the moon that is visible from Earth. The astronauts will now prepare their life support units for the first moonwalk.
Amanda, the life support units have oxygen tanks, water, and all the radio equipment in big backpacks.
I know, and Dad told me. The space suits cost more than $1 million each.
The sun filters on their helmets are made of gold foil. On Earth, the atmosphere blocks most of the sun rays, but on the moon, the sun would burn your skin in a few seconds. The spacesuits also keep the astronauts at the right temperature.
You've been teaching them everything, haven't you, Miss Collins?
Well, this is one of the greatest scientific achievements of the century. I want them to remember everything.
I'm ready to open up the hatch now. I'm taking out the camera and turning it on.
What you now see on your television screens is live footage from the moon.
Neil will have to jump the last 3 feet to the ground. We had to make the ladder short to save on weight.
I can't believe this is actually happening.
I'm stepping onto the ladder now, down to the bottom step.
The images of Neil Armstrong climbing out of the lunar module are among the most famous in the world. His spacesuit was bulky and his movements were awkward. The low gravity environment, he stepped casually down the ladder, hopped off the end hopped off the end and landed on the surface of the moon. He said,
That's one small step for mankind and one giant leap.
Wait. A few minutes later, Buzz Aldrin joined in.
The astronauts will perform several experiments on the moon. One involves running at full speed and then trying to stop in a low-gravity environment. In the vacuum of space, the astronauts must be careful not to tear their spacesuits. The suits recreate the air pressure on the Earth, and the loss of pressure could result in injury or death.
This moon dust is strange stuff, and the distance it looks white, almost blue, and in our other places it seems kind of yellow. Beneath our feet, it's mostly gray. When I pick it up, it looks brown or black.
The horizon seems much closer here than it does on Earth. But wait, what's that I see coming on this one side?
What are you seeing, Eagle?
It's the Earth rising like a petal of sunrise in the morning. It's the most beautiful thing I've ever seen.
For the first time in history, people look at the Earth from the moon. The astronauts will place a plaque near the spot where the Eagle landed. The plaque reads, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind."
Since that day, scientists have continued to explore outer space for outer space. The International Space Station makes it possible for humans to live in orbit for months. The Hubble telescope takes glorious photographs of the stars light years away. Rows have photographs of the surface of almost every planet in the solar system. But no human has ever traveled farther than Neil Armstrong, Buzz Aldrin, and Mike Collins. Even if we never travel beyond the moon, we always have known we are not bound to Earth. We truly are ambitious explorers of the universe.